You've seen these problems in the past in 6th grade and even as a problem of the day today. They always go something like, well, what we did today is Chloe can paint a room, takes 3 hours. Lillian, whoops, sorry Lillian. This is in honor of Math Counts kids. Lillian, 2 hours to paint a room, the same room, alone. Working together, how long will it take? Okay, I know that's shorthand. I hope you understand the problem. If Chloe can paint a room in 3 hours, Lillian can paint the same room in 2 hours. Working together, how long will it take? In the past, and this was a solution that many use today, we think about it like this, and this is the part that actually plays into what we're doing today. If it takes Chloe 3 hours to do the whole thing, she can get 1/3 of the room done per hour. This is her rate. Remember that. 3 hours for the whole thing is 1/3 of the room per hour. 1/3 of 6 is 2 squares. And we made 6 so that their things would both go into it. 1/2, if Lillian can do the whole thing per hour, whole thing in 2 hours, her rate is 1/2 per hour. Make sure you remember that. Half of these 6 squares is 3. Okay, so we've sort of obscured the lines here, but it's clear that we can get 5 of these boxes done in 1 hour. In other words, 5/6 done in 1 hour. So that means the leftover box, one box, takes 60 minutes divided by 5, or 12 minutes. The answer is 1 hour and 12 minutes. So that's how we reason it. But in using algebra, it can actually be quite simple. What we already know. Whenever we're talking about how fast something takes, we can say rate times time, and in this case, will equal the work done. If I want to chart that same problem, I've got Chloe. And as we said, if she can do the whole thing in 3 hours, her rate is 1/3. And Lillian, I'm going to abbreviate, if she can do the whole thing in 2 hours, her rate is 1/2. Just like when we did rate times time equals distance problems, when the variable is in time, you have to ask yourself, are they starting at the same time and finishing at the same time? If they are, as they are in this problem, they are represented by the same variable. Note, that will not always be the case. So, rate times time equals work done. 1/3 times t is t over 3, or you could call it 1/3 t. I like this way. 1/2 times t is t over 2. And from here we can get our equation, and this is one of the things that's really easy about this. We always want the whole job to be done. A whole pizza, the whole pie, 100%. However you think of it, it means that t over 3 plus t over 2, Chloe's work, plus Lillian's work, has to equal 1. From there, it's dead easy. 2t plus 3t equals 6. 5t equals 6. T is 6/5, which is 1 1/5 hour, and you do need to know that that is 1 hour and 12 minutes. Moving on, are just slightly more complicated. We did do something like this today in class. We talked about a mail handler can sort the mail by himself in 3 hours. With an assistant working together, it takes 2 hours. So in all of these things, I am, sorry for that interruption, with an assistant it takes 2 hours. The question is, what would the assistant's rate be if working alone? Okay, I don't want to write all the words, but you get the idea. This mail handler guy can sort the mail by himself in 3 hours. If he works with his assistant, they're working together, it takes 2 hours. What is the assistant's rate alone? So we've got the main guy, and we've got his assistant. We know that rate times time is equal to work done. The male assistant, if he can do the whole job in 3 hours, I hope you've got this down, yes, his rate is 1/3. The assistant is the thing we don't know alone, that we don't know. So we don't know how long it would take him alone, but however long that is, he can get 1/x of that done per hour. Now, how long are they working? Well, it talks about where they're working together. It takes 2 hours. So when they work together, it's 2 hours. So the male handler alone can get 2/3 of the job done. The assistant can get 2/x. So 2/3 plus 2/x equals the whole job. I'm not going to solve that because I do know that you can do it. The last up, a chart for a problem that's on page 328. It's number 8. It talks about Brett can groom a horse by himself in 50 minutes. After working 10 minutes, he was joined by Angela. After 10 minutes, joined by Angela. They finished in 15 minutes. What is Angela's rate? How long would it have taken her alone? Okay, so we know rate times time equals work done. We've got Brett. He normally takes 50 minutes, therefore his rate is 1/50. Angela, the thing we don't know, so her rate is 1/x. That means we must have numbers for time if our variable is in the rate. So let's look at Brett. He works for 10 minutes and then he's joined by Angela and finishes in 15 minutes. So for a total, he's working 25 minutes. Angela's total minutes is 15. So Brett's work done is 25/50, or 1/2 of the job. Angela is 15/x. And the equation is 1/2 plus 15/x equals, you guessed it, 1, the whole job. Okay then, that's as much as I'm going to show you. You can solve the rest, and I think that you'll do fine with homework tonight.